Hello, welcome, settle in and prepare yourself for one of the most monumental possibilities in all of existence, the Big Crunch.
Did you know that if the universe contains enough mass, gravity itself could one day slow the expansion of galaxies and begin a journey back inward, causing the entire cosmos to gradually gather itself into a slow and majestic contraction toward its beginning? Today, we observe stars drifting farther apart through an ever-growing emptiness. Yet science continues to investigate what might happen if this universal breath were to reach its maximum limit. If the fabric of space is curved, could the destiny of everything that exists be a return to a warm and infinitely dense embrace, reversing the arrow of time itself? Together, we will explore the central idea behind the Big Crunch and examine the scientific foundation behind the concept of critical density. We will walk through the studies that describe how such a reversal could occur, and imagine a universe where astronomical distances begin to shrink until galaxies once again draw close to one another. We will discover the consequences of a universe that compresses inward, and how this theory connects to the ultimate fate of everything. But before we continue, I'd like to ask for your support. If you enjoy calm explorations of science like this, consider subscribing to Cosmos for Rest, and share this story with someone who might also appreciate a quiet journey through the universe. Your support helps this project continue bringing peaceful science to nights of rest. Now, relax, close your eyes, and allow science to gently guide you. To understand the magnitude of what we call the Great Contraction, or the Big Crunch, we must first quiet our immediate perception of time and look at the sky as if it were a breathing organism. Billions of years ago, the universe began a frantic expansion, a great exhalation that sent matter, light, and energy in every possible direction. Since that primordial moment, galaxies have been moving away from one another, like dots on the surface of a balloon that keeps inflating without pause. Yet physics teaches us that every action is balanced by forces, and at the heart of this vastness lies an invisible, silent, persistent force: gravity. The story of the Big Crunch is, in essence, the story of gravity's final victory over the escape of the stars. It is the moment when the universe decides it has drifted far enough, and that it is time to return home. Imagine that space is not merely emptiness, but an elastic and sensitive fabric shaped by everything it contains. Einstein showed us that matter tells space how to curve, and space tells matter how to move. If there is enough matter spread across this cosmic fabric, dust, stars, planets, black holes, and the mysterious dark matter, the combined weight of everything that exists begins to act like an invisible brake. At first, this slowing is imperceptible, a change so subtle that even our most sensitive instruments would struggle to detect it. It is like the instant when a ball thrown upward reaches its highest point and, for a brief fraction of a second, appears to hover motionless before the Earth pulls it back. In that cosmic pause, expansion ceases. The universe reaches its maximum size, a moment of perfect stillness where the force of the original explosion and the pull of gravity balance one another completely. From that moment of stillness, the direction of the journey reverses. What was once constant separation becomes a slow and inevitable approach. The galaxies we spent ages watching fade into the reddish horizon begin to show signs of return. It is important to understand that this does not happen like a sudden fall, but as a smooth and organic movement. Science uses the concept of critical density to predict whether such a scenario is possible. If the average density of the universe is greater than a certain value, the geometry of the cosmos is described as closed, meaning it has positive curvature, like the surface of a sphere. On a sphere, if you travel in a straight line long enough, you eventually return to where you started. The Big Crunch is the natural destiny of a universe with this shape. It is the closing of a cycle where the end is already contained within the beginning. In this first stage of contraction, the change in the night sky would be visually fascinating to a patient observer. For millions of years, distant galaxies have displayed what we call redshift, an effect caused by the stretching of light waves as space expands. As the Big Crunch begins to take control, this phenomenon slowly reverses, giving way to blue shift. The waves of light sent by galaxies that are now approaching us begin to compress, becoming shorter, more energetic, and shifting toward the higher frequencies of the spectrum. The universe, which for so long appeared to be fading and cooling, begins to show the first signs that it is awakening into a phase of greater intensity. It is the beginning of a serene descent, where vast distances slowly transform into closeness. This transition deeply alters our understanding of the arrow of time. Although time continues to flow forward in a local thermodynamic sense, the structure of the stage on which life unfolds is changing its configuration. Cosmic isolation, which defines our current era, begins to dissolve. In an expanding universe, the final destiny appears to be absolute solitude, where every galaxy becomes an unreachable island, surrounded by an ocean of nothingness. In the scenario of the Big Crunch, the destiny is union. It is a return to the original unity, where everything once separated by the great explosion begins to feel gravity's call to gather once again. This is not immediate destruction, but a reconfiguration of reality, where the fabric of space-time slowly folds in upon itself with mathematical elegance. We can think of this initial phase as the evening of a long cosmic day. Light still exists, stars still shine in their orbits, yet there is a subtle sense of gathering in the air. The physics behind this process is governed by the Friedmann equations, which describe how the universe evolves based on what it contains. If the cosmological constant, that mysterious energy pushing space outward, is eventually overcome by gravitational attraction, the destiny is sealed. The universe ceases to be a solitary explorer searching the edges of nothingness and becomes instead an architect gathering its materials for a new creation. This shift transforms the cosmos from an open and potentially infinite system into a closed and cyclical one, where every atom in your body, every grain of stardust, and every thought that has ever existed is destined to meet again at a common point in the distant future. As we immerse ourselves in this idea, we begin to see that the Big Crunch is not the opposite of life, but another phase of its existence. It is the maturation of a system that has exhausted its possibilities for outward growth and now seeks inward integration. The early stage of contraction carries a silent beauty. Distances that once required billions of light years to cross begin to shrink meter by meter, kilometer by kilometer. The great structures of the universe, the superclusters of galaxies that form the cosmic web, start moving toward one another, guided by the gravitational currents they themselves created. It becomes a dance of epic proportions, where the rhythm is set by the total mass of everything that exists. The calm of this early stage is essential for understanding the progression that follows. Before the heat rises and before density becomes overwhelming, there is this long period of graceful approach. It is like the beginning of an embrace that will take trillions of years to complete. Science invites us to contemplate this possibility not with fear, but with the admiration reserved for a perfect, natural cycle. Where everything began, everything must eventually end, perhaps so that it may begin again. The Big Crunch represents the supreme symmetry of nature, the idea that the universe is self-sufficient and capable of renewing its own structure through gathering itself inward. It is the first step of a gentle descent toward primordial density, an invitation to abandon the notion of a linear ending and embrace the possibility of an eternal return. To imagine what it would feel like to live in a universe that has begun its return through the Big Crunch, we must first adjust our perception of the passage of ages. For an inhabitant of a planet orbiting a stable star, daily life would not undergo an abrupt or catastrophic transformation during the first millions of years of contraction. In fact, everyday experience would be marked by a subtle change in the tapestry of the night sky, a slow evolution that would gradually reshape how humanity, or any conscious civilization, understands its place within the hierarchy of the cosmos. If today we live in an era of isolation, where neighboring galaxies seem to be saying farewell to us in an accelerated escape, the routine under the influence of the Great Contraction would instead be one of gradual reunion. The horizon, which once expanded into emptiness, would begin to bring news of distant worlds drawing closer. The experience of this shift would first appear in the instruments of astronomy. Future scientists would begin to notice that the calculations of distance, which for billions of years had always produced larger numbers, would now reveal that the space between objects is shrinking. This new reality would subtly alter the feeling of cosmic destiny. In the model of eternal expansion, the future leads toward cold and darkness. In the model of the Big Crunch, daily life becomes a preparation for warmth and light. Civilization would begin to observe the sky not as a cemetery of fading lights, but as a stage where the actors are returning to the center. Constellations, which take millennia to change shape in the human sky, would begin to distort and reform more noticeably as the speed of contraction slowly increases across generations. Imagine the nights of observation on a world where the Big Crunch governs the cosmos. The blue shift described earlier would no longer be merely a line on a graph, but a visible feature of the heavens. Galaxies that today appear only as faint smudges in powerful telescopes would gradually grow brighter and larger in the night sky. The routine of an astronomer would involve cataloging new cosmic neighbors. The Milky Way, already destined to merge with the Andromeda Galaxy and other members of the local group, would see this union accelerated by the contraction of the very space that separates them. The sky would become more populated, more vibrant, and in a strange way, more welcoming. The sense of cosmic loneliness that shaped scientific thinking in the early 21st century would slowly give way to a growing feeling of integration. Biological life, however, would remain protected by the immense scale of space for a very long time. Distances in the universe are so vast that even during contraction, stars and planets would still have more than enough room to exist without immediate collisions. What would truly change is the perception of the future. A civilization living during the Big Crunch would know that its cosmic territory is slowly shrinking. This awareness could inspire a different kind of existential planning. If expansion once suggested infinite resources and endless frontiers, contraction teaches about limits and the value of coexistence. The politics and sociology of such civilizations might be shaped by the understanding that the universe itself is converging, encouraging cooperation among distant star systems that are gradually becoming closer than ever before. As millennia turn into eras, the density of radiation throughout the universe would begin to rise, subtly affecting the climatic routines of planets. The cosmic microwave background, which is the cold echo of the Big Bang, would begin to warm. In our current time, this radiation is only about 3 degrees above absolute zero. In a contracting universe, that temperature would slowly begin to climb. Planetary environmental monitoring would eventually need to account for this cosmic warming. It would not be caused by industrial activity or the proximity of a star, but by the simple fact that the volume of the universe is shrinking, compressing the energy contained within it. Life would adapt beneath a sky that grows steadily more radiant, where true darkness becomes increasingly rare. Living through the Big Crunch would be an experience of witnessing the symmetry of creation itself. If the routine of the Big Bang was the birth of complexity from simplicity, the routine of contraction would be observing how that complexity prepares to be reintegrated. Vast structures such as nebulae and stellar nurseries would become compressed, possibly triggering new waves of star formation before the final collapse. The experience of this era would therefore be one of increasing intensity. What begins as a subtle change in equations eventually transforms the entire celestial landscape. Stars that once appeared as isolated points in darkness would share the sky with galactic disks visible to the naked eye, creating nights of indescribable beauty, illuminated by the light of billions of approaching suns. This phase of existence would also carry a deeply contemplative aspect. The Big Crunch invites reflection on the nature of letting go. If the universe is returning to its original state, then every structure, every memory, and every piece of matter is part of a long journey of return. The routine of a conscious mind aware of this truth might become one of appreciating the present moment with renewed intensity. The contraction is not something happening to us, but a process of which we are part. We are passengers aboard a ship that, after exploring the open ocean, is slowly returning to its harbor. The vast waves and distant horizons give way to the calm presence of land appearing in the distance. To live through contraction is to feel the gentle and constant pull of gravity, as an invitation to rest after an immense journey of expansion and discovery. Eventually, life under the Big Crunch would be defined by light. The universe would grow brighter and brighter. A moment would arrive, far in the distant future, when the night sky would cease to exist altogether. The light of every star and galaxy, compressed into a steadily smaller cosmic volume, would fill every corner of space. Day and night would merge into a perpetual golden twilight. It is an image of profound tranquility and overwhelming energy at the same time. The cosmos would become a temple of light, where matter prepares for its final transformation. Seen through the lens of everyday experience, the Big Crunch ceases to be a dry mathematical theory and becomes the grandest sensory event imaginable, the moment when the universe becomes fully aware of itself through heat, light, and ultimate closeness. To dive into the deeper mechanisms that govern the Big Crunch, We must understand that the universe operates like a vast thermal and gravitational engine, where every gear is made of space and time. The fundamental mechanism that sustains this great contraction is the energy density of the cosmos. Science works with a fascinating concept known as the density parameter, represented by the Greek letter omega. If the value of this parameter is greater than 1, the destiny of the universe is sealed. This means that the total quantity of ordinary matter, dark matter, and radiation carries such immense gravitational attraction that the energy of the initial expansion cannot escape forever. It becomes a kind of containment strategy written into nature itself. The universe launches outward, yet its own substance acts as an invisible anchor that eventually halts the flight. One of the deepest elements of this process involves the role of entropy in a contracting system. In traditional physics, entropy, which we can understand as the degree of disorder in a system, always tends to increase. In an expanding universe, this leads to what is called heat death, where everything spreads out and cools until no usable energy remains to perform work. The Big Crunch introduces a dramatically different scenario. As space shrinks, disorder does not disappear, but it becomes compressed. Imagine a vast ballroom where people gradually move farther apart until each one stands alone. This is expansion. Now imagine the walls of that ballroom slowly closing in. Even if everyone continues moving chaotically, they are forced to interact, collide, and exchange energy. The mechanism of contraction transforms the universe into a kind of cosmic pressure chamber, where gravity's strategy is to concentrate all the energy and information that once spread across immense distances. Another essential mechanism is the reversal of the Doppler effect on a universal scale. In our current era, we observe redshift because the space between us and distant galaxies stretches, lengthening the waves of light. During the Big Crunch, the deep mechanism becomes blue shift. As the universe contracts, the waves of light are compressed, increasing their frequency and therefore their energy. This produces a cascading effect on the background radiation that fills space. That faint glow, the remnant light from the beginning of the universe, begins to gain energy again. What was once an invisible microwave whisper becomes visible light, then ultraviolet radiation, then X-rays, and eventually intense gamma rays. The deeper mechanism at work here is a kind of thermodynamic reversal. The universe reheats itself simply by shrinking, gradually recovering the temperatures that existed during its earliest moments. Gravity's strategy during contraction also reshapes the architecture of galaxies. In a stable or expanding universe, galaxies maintain a certain structural integrity within their clusters, but within the Big Crunch scenario, gravitational tidal forces become overwhelming. As the total volume of the cosmos decreases, galaxies begin to overlap and merge on enormous scales. This is not merely a sequence of isolated collisions, but a collective fusion of cosmic structures. The deeper mechanism here is the dissolution of boundaries. The space that once separated stellar systems fades away, and the universe begins to behave like a single immense fluid composed of stars and gas. Individual stars rarely collide because of the immense distances between them, yet they begin to exist in an environment where external radiation rivals the heat of their own nuclear cores. At this stage, one crucial element, often overlooked, is the role of black holes. They function as the great collectors in gravity's strategy of contraction. As the universe becomes denser, black holes begin consuming surrounding matter with increasing efficiency. As galaxies merge, the supermassive black holes at their centers also encounter one another, combining into structures of unimaginable scale. The mechanism here resembles a race against time. The universe is contracting toward a singularity, and black holes act like cosmic vacuum systems, converting mass into the pure curvature of space-time. It is almost as if the cosmos organizes its own matter before the final collapse, concentrating the densest material into points of extreme gravity. The physics of space-time itself reveals profound secrets about the nature of the vacuum during the Big Crunch. There is scientific debate about whether the fundamental constants of nature, such as the speed of light or the strength of gravity, would remain unchanged under such extraordinary pressure. Some theoretical models suggest that the strategy of contraction could cause shifts in the laws of physics as the universe approaches Planck-level densities. The mechanism of contraction may literally squeeze the quantum vacuum itself, forcing the virtual particles that constantly appear and vanish into interactions unlike anything we observe today. Space and time would cease to be passive stages, and instead become turbulent actors, filled with fluctuations that prepare the universe for its return to singularity. Time itself undergoes a fascinating distortion. According to general relativity, intense gravitational fields slow the passage of time. In the mechanism of the Big Crunch, as the density of the entire universe increases, the global flow of time begins to behave in unusual ways for a hypothetical outside observer. If one could somehow watch the contracting cosmos from beyond it, the cosmic clock would appear to slow as density climbs toward infinity. It becomes a subtle resistance written into reality itself. The harder the universe presses toward collapse, the more the final moment stretches outward in time. This theoretical depth reminds us that the Big Crunch is not merely a collapse, but a delicate negotiation between the geometry of space and the energy contained within it. Finally, we must consider the mechanism of spatial curvature. In a universe destined for the Big Crunch, geometry must be finite. This means that nature has created a system that ultimately closes in upon itself. There is no external region into which the universe is contracting. Rather, the very concept of distance is being redefined moment by moment. The profound element here is the realization that the cosmos is an indivisible whole. The Big Crunch becomes the ultimate expression of that unity. Every particle is connected to every other through gravity, and the mechanism of return demonstrates that nothing in the universe is truly independent. All of existence participates in a vast strategy of reunification, where the complexity of galaxies and stars is slowly guided back toward the simplicity of the original point. Within the tapestry of the Big Crunch lie mysteries that challenge our conventional logic and reveal a universe far stranger and more fascinating than appearances suggest. One of the deepest secrets of this theory lies in the possibility of a reversal of the arrow of time. Some theoretical physicists, while exploring the field equations of a contracting cosmos, have raised a daring hypothesis. If the expansion of space is linked to the increase of entropy and to our perception of time flowing from past to future, could a global contraction reverse this process? In such a radical scenario, one might imagine a universe where disorder begins to decrease and events appear to move backward. Most scientists today believe that thermodynamics would maintain its direction, yet the mere fact that the laws of physics allow this discussion reveals how little we truly understand about the intimate relationship between gravity and chronology. Another surprising discovery surrounding the Big Crunch concerns the fate of light itself. In a shrinking universe, a phenomenon known as an inverse global event horizon may emerge. Today, due to accelerated expansion, there are galaxies whose light will never reach us again. Their signals are forever lost beyond the expanding boundary of the observable universe. In a contracting cosmos, this secret reverses. The universe begins to recover light that once seemed lost in the vastness. Regions of space that have remained disconnected for billions of years slowly come back into visual contact. It is as if the universe were recovering its memory, gathering information from distant corners that were separated in the earliest moments of time. This possibility suggests that the final era of the cosmos might be a moment of cosmic omniscience, when the light emitted by every star that ever shone gathers together once more before the final collapse. There is also the mystery of what could be called the blue background radiation. Today, the faint glow left over from the birth of the universe exists as a cold and invisible microwave signal. Yet one of the most poetic predictions of the Big Crunch is that as space compresses, this primordial radiation becomes re-energized. It would begin to shine again within the visible spectrum. Imagine a secret kept for trillions of years. The night sky, instead of remaining black, would emit a soft and constant glow from every direction, a gentle amber luminosity that would gradually intensify into white and eventually into a brilliant blue radiance. This mystery transforms the death of the universe into a spectacle of light, where the heat of the beginning is recycled to illuminate the end. The cosmos would not conclude in darkness, but in a radiant culmination where the energies of past and future converge. Another rare insight from studies of contraction concerns the behavior of the quantum vacuum under extreme pressure. We already know that the vacuum is not truly empty, but filled with virtual particles that constantly appear and vanish. The mystery arises when the fabric of space-time itself begins to compress. Some theories suggest that the vacuum could undergo a phase transition, altering the fundamental properties of matter. Atoms might cease to exist long before the final collapse. dissolving into a dense sea of quarks and gluons under the pressure of the surrounding radiation. This reveals an important secret of particle physics. Contraction does not simply bring planets closer together. It dismantles the very structure of matter, returning chemical complexity to a state of pure energy. It is as if the universe possesses its own mechanism of purification, reducing everything to its simplest essence before beginning another cycle. There is also the mystery of gravitational echoes. During contraction, enormous collisions between supermassive black holes would generate gravitational waves of unprecedented strength. Instead of dispersing endlessly through infinite space, these waves would be focused and amplified by the curvature of a closed universe. In such conditions, space-time itself might begin to resonate like a bell struck again and again. These vibrations could carry complex patterns, almost as if the universe were singing its own elegy through waves of gravity. This idea hints that the structure of the cosmos may be inherently musical, and that the Big Crunch would represent the final crescendo of a symphony that began with the Big Bang. Many people wonder what lies beyond the final singularity, and here we encounter perhaps the greatest mystery of all, the Big Bounce. Some interpretations of quantum mechanics suggest that the universe might never reach an infinite density. Instead, when the cosmos contracts to a minimum scale, quantum effects could cause it to rebound, initiating a new expansion. In this possibility, the Big Crunch is not an ending, but a transition. The mystery then becomes whether information from our universe, its physical laws, or perhaps even subtle traces of our existence, could pass through this cosmic bottleneck and emerge into the next expansion. Could the universe be a system that endlessly dies and is reborn, like a cosmic phoenix? The idea of a cyclic cosmos remains one of the most intriguing and comforting possibilities in modern cosmology. Another enigma concerns what some physicists describe as a variable cosmological constant. Today, dark energy appears to drive the accelerated expansion of the universe. Yet some scientists wonder whether this energy might not be truly constant at all. If it behaves as a dynamic field, it might weaken over immense stretches of time and eventually become attractive rather than repulsive. Such a transformation would completely alter our understanding of the universe's fate. The deeper mystery lies in what could trigger such a change. Could it be a process embedded in the laws of nature since the first instant of cosmic history? The possibility hints that the universe might follow a hidden script, a structural logic guiding matter from expansion toward contraction as cosmic time matures. Finally, the secret of absolute proximity reveals something profound about existence itself. As distances shrink, the concept of otherness begins to dissolve. Philosophically, the Big Crunch suggests that separation is only a temporary illusion created by expansion. In the end, everything returns to unity. Every particle, every star, every fragment of matter ultimately shares the same destiny of reunion. The journey toward contraction becomes a rediscovery of fundamental oneness, where the distinction between observer and universe fades away. The Big Crunch closes the cosmic circle and reveals the deepest secret of all, that we were never truly separate from the universe that gave rise to us. As we explore the connections and impacts of the Big Crunch, it becomes clear that this is not an isolated event within physics, but a phenomenon that resonates across every layer of scientific knowledge, from quantum mechanics to theoretical biology. The first major connection lies in the deep interdependence between the total mass of the universe and the very geometry of reality. The Big Crunch implies that the cosmos is a closed system, fundamentally altering the way we understand conservation laws. In a universe that expands forever into infinity, energy appears to dilute into an endless void. But in the scenario of contraction, every particle of light and every fragment of matter participates in a continuous feedback cycle. The impact of this idea is the realization that the universe possesses its own internal ecology, where nothing is wasted, and everything eventually contributes to the final collapse and perhaps to a new beginning. A fascinating connection emerges within thermodynamics. We usually associate the growth of entropy with an inevitable drift toward chaos. Yet the Big Crunch introduces a far more subtle relationship between heat and order. As space contracts, the cosmic background radiation, currently a cold remnant of the universe's birth, begins interacting with matter more actively once again. The impact of this connection is a reheating of the interstellar medium. This creates a bridge between cosmology and stellar physics. Stars, which normally fade and die as their nuclear fuel is exhausted, would instead experience the influence of external heat from the surrounding universe. The warming environment of space could prevent stars from cooling, keeping them glowing under the pressure of external radiation. This connection reveals that the fate of a single hydrogen atom within a distant star is inseparably linked to the destiny of the entire fabric of space-time. The influence of the Big Crunch on the structure of dark matter also forms a crucial connection. Although invisible to our eyes, dark matter acts as the gravitational scaffolding that holds galaxies together. During cosmic contraction, dark matter would be among the first components to feel the increasing compression of space, deepening gravitational wells across the universe. The connection here is that dark matter sets the rhythm of the final cosmic dance. It accelerates the merging of galaxies and the formation of colossal clusters. The practical impact is that the universe gradually transforms from a collection of isolated islands into a single immense ocean of gravity, where visible matter becomes only the foam upon waves of a far larger and unseen force, pulling everything back toward the center. In the realm of biology and evolution, the Big Crunch raises profound questions about the longevity of life. Life as we understand it depends on energy gradients, differences in temperature that allow systems to perform work and process information. A universe that gradually warms during contraction presents a unique existential challenge. The impact is that the time available for biological life becomes limited not by cold, but by excess energy. This forces us to reconsider evolutionary strategy. In a cosmos destined for contraction, life might need to adapt to ever higher energy environments, perhaps evolving into forms capable of processing information under extreme conditions or transitioning into digital or quantum-based systems of consciousness. Philosophically, this reveals life as a temporary bloom within a narrow window between the cool aftermath of the Big Bang and the rising heat of the Big Crunch. There is also a rigorous mathematical connection between the Big Crunch and advanced theories such as string theory and quantum gravity. Many high-energy physics models suggest that additional spatial dimensions, currently curled into microscopic scales, could be influenced by the contraction of the three-dimensional space we perceive. The impact of this connection is the possibility that as the universe shrinks, the familiar forces of nature may begin to merge. The electromagnetic force and the nuclear forces might reunify into a single primordial interaction, just as they are believed to have been unified in the earliest moments after the Big Bang. This suggests that the Big Crunch acts as a cosmic laboratory of unification, where the distinctions that allowed complexity to emerge are gradually dissolved. Another profound connection concerns the nature of information itself. Modern physics grapples with the question of whether information can ever truly be destroyed. In the context of the Big Crunch, the entire history of the universe, encoded in the position and state of every particle, would be carried back toward the final singularity. If contraction is followed by a rebound, the implications become even more intriguing. Could the information of one cosmic cycle influence the next? This possibility transforms the universe into a form of cyclical memory system, where each contraction processes the data of the previous expansion and prepares the conditions for a new cosmic era. Cosmology begins to intersect with information theory, suggesting that the universe may operate like an immense processor that periodically resets itself. Chemical processes are also deeply connected to the fate of contraction. As radiation density grows increasingly intense, complex molecules would eventually break apart under energetic bombardment. Even atomic nuclei could begin to disintegrate through photodisintegration. The impact is a reversal of stellar alchemy. Elements that took billions of years to forge inside stars, carbon, oxygen, iron, gold, would gradually dissolve back into simpler particles such as protons and neutrons. This reveals a universal recycling cycle. Complexity exists only within a specific window of cosmic conditions. When those conditions disappear, chemistry dissolves back into particle physics, closing the chapter of structured matter. Finally, the most intimate connection is the one that unites the macrocosm with the microcosm. The Big Crunch reshapes our worldview by demonstrating that there is no true separation between observer and observed. If the universe is a single system moving toward contraction, then every cell in our bodies and every star in the sky share the same ultimate trajectory. The impact of this realization is a sense of universal solidarity. Every form of matter, every conscious being, and every distant galaxy travels along the same gravitational current. This perspective transforms our philosophical outlook, reminding us that the story of the cosmos is also our own story. In the grand movement toward reunion, nothing exists in isolation, and every fragment of existence participates in the same profound return. The relationship between humanity and the idea of the Big Crunch goes far beyond mathematical equations and enters deeply into the realm of collective consciousness, philosophy, and the way we assign meaning to existence itself. Since the first humans looked up at the night sky, there has been a persistent desire to understand whether time is a straight line, stretching endlessly into the unknown, or a circle that eventually returns to its point of origin. The Big Crunch offers humanity a powerful metaphor of eternal return, an idea that echoes through ancient cultures and mythologies. The notion that the universe may experience cycles of birth, growth, and gathering reflects the human experience itself, of waking and sleeping, of activity and rest. When we contemplate the Great Contraction, we are not simply examining a cosmological model. We are confronting our own longing for closure and completeness. The cultural impact of this idea is immense. During the 20th century, when science first began to suggest that the universe might have an end, humanity experienced a subtle shift in worldview. If the ultimate fate of the cosmos is a return to singularity, the meaning of our achievements takes on a different perspective.
In a universe that contracts into a final point of unimaginable heat and density, none of the physical structures we build, monuments, cities, or spacecraft, can survive the ultimate compression.
This realization leads to a profound philosophical consequence. The value of human life moves away from permanence and toward experience. If the stage upon which we act will eventually be folded away and prepared for another cosmic performance, then the beauty of the present moment becomes our most precious treasure. Humanity's relationship with the universe becomes a lesson in appreciation rather than an obsession with permanence. In literature and the arts, the Big Crunch has inspired narratives that explore the themes of ending and renewal. Writers and poets often describe the universe gathering itself as a metaphor for memory. Just as the Big Crunch gathers every photon and every fragment of matter back into a single point, human consciousness often gathers a lifetime of experiences into moments of reflection and wisdom. This symbolic connection builds a bridge between the microscopic scale of the human mind and the vast scale of galaxies. The social impact of this vision encourages a more integrated mindset. When we recognize that the ultimate destiny of the cosmos is unity, the divisions we create among ourselves, borders, ideologies, and conflicts, begin to feel insignificant compared to the grand and inevitable convergence of the universe. Humanity's relationship with this idea also influences how we think about environmental responsibility and technological progress. If the universe is a closed system moving through cycles of expansion and contraction, balance becomes a central principle. The Big Crunch reminds us that expansion without limits is not the only rhythm of nature. Gathering, integration, and equilibrium are equally fundamental. This perspective can shape the philosophy of future civilizations, encouraging a focus on harmony rather than endless consumption. A society aware of living within a cyclical cosmos might prioritize the preservation of knowledge, culture, and life, rather than the unchecked exploitation of cosmic resources. From the perspective of psychology, the Big Crunch reflects both our deepest fears and our deepest hopes. The idea of collapse is a powerful archetype in human thought, yet modern cosmology transforms that fear into something ordered and majestic. The thought that the universe knows how to return to its origin can evoke a surprising sense of comfort. Instead of confronting the terrifying image of infinite emptiness, we encounter the idea of a complete cycle. Humanity has always searched for patterns to give meaning to the unknown. The Big Crunch offers one such pattern, the possibility that the end of the universe is not a void but a reunion, a moment when everything returns to the same cosmic center. The theme also resonates within the history of spirituality and religion. Many ancient traditions describe the universe as a cyclical process long before modern physics existed. In certain Eastern philosophies, the cosmos is described as the breath of a divine presence, an exhalation that creates worlds, and an inhalation that gathers them back again. The dialogue between these ancient intuitions and modern cosmology has created a fascinating bridge between poetic imagination and scientific investigation. The convergence of these perspectives suggests that humanity has long sensed the possibility of cosmic cycles, even before mathematics provided the language to explore them. In the context of space exploration, the Big Crunch reshapes how we might imagine the distant future. If the universe eventually contracts, the colonization of distant galaxies would no longer represent an escape into endless expansion. Instead, exploration would become part of a long journey toward reunion. The cosmos would slowly become smaller, bringing distant civilizations into closer proximity. In such a future, humanity might discover that the unknown beings scattered across the galaxies are not strangers at all, but fellow travelers aboard the same cosmic vessel, slowly returning to its origin. Ultimately, humanity's relationship with the Big Crunch reflects the extraordinary capacity of our species to understand the universe that created us. It is remarkable that being so small, living on a modest planet orbiting an ordinary star, can contemplate the ultimate destiny of space and time. This realization inspires both humility and dignity. We are the portion of the universe that has awakened to observe its own story. In contemplating the possibility of the Big Crunch, humanity fulfills a unique role. We become the narrators of the cosmos, witnesses to the grandeur of existence before it gathers once again into unity. When we project the future of the Big Crunch theory, we enter a domain where cutting-edge science meets the boldest frontiers of theoretical imagination. The fate of this idea depends largely on discoveries that will emerge in the coming decades regarding the nature of dark energy. At present, observations show that the expansion of the universe is accelerating, which appears to challenge the possibility of a future contraction. Yet the future of this topic points toward a possible revision of that certainty. Cosmologists are investigating whether dark energy is truly an immutable constant, or whether it may possess an internal dynamic that could weaken or even reverse its effect in the distant future. If dark energy turns out to be a scalar field that gradually loses strength across cosmic time, the Big Crunch could once again become a central pillar in our understanding of the ultimate fate of the universe. One of the most promising paths for the future of this theory lies in loop quantum gravity. This approach proposes that space-time is not a smooth, continuous fabric, but instead is composed of discrete units, tiny atoms of geometry. When the universe contracts and reaches densities close to the Planck scale, these units of space could generate an immense repulsive force. Within this framework, the future of the Big Crunch would not involve an absolute singularity of annihilation, but a mechanism of rebound. In this perspective, the collapse becomes what scientists call the Big Bounce. The implications are revolutionary. The universe would no longer be understood as a singular event, but rather as a perpetual cosmic rhythm, where each contraction prepares the conditions for a new expansion, renewing the laws of physics and the landscape of existence. Another future direction for research involves connecting the Big Crunch with the concept of the multiverse. Some theoretical models propose that our universe may be only one bubble within a much larger cosmic ocean. In such scenarios, the contraction of one cosmic bubble could trigger the birth of others. Future scientific investigations may search for subtle scars or patterns in the cosmic microwave background, faint imprints that could be remnants of a contraction from a previous cosmic cycle. If such evidence were discovered, it would fundamentally transform our understanding of time. Rather than a straight line beginning with a single Big Bang, cosmic history might be an endless sequence of expansions and contractions, unfolding across unimaginable timescales. Technological innovations in gravitational wave observatories will also play a crucial role in the future of this research. In the coming decades, scientists may be able to detect vibrations in space-time, originating from the earliest moments after the birth of the universe. These waves carry information about the geometry of the cosmos. If they reveal that the universe possesses a closed geometry, the mathematical foundation for the Big Crunch would gain strong support, regardless of the present acceleration of expansion. Astronomy of the future may therefore rely not only on observing light, but on listening to the subtle harmonies of space-time itself to understand whether the cosmos is destined to collapse. Another frontier concerns the possibility of a vacuum phase transition. Some theoretical models suggest that the vacuum state of our universe might not represent the lowest possible energy configuration. If a more stable state exists, the universe could one day transition toward it. While this idea sometimes appears in discussions about catastrophic cosmic change, the more serene vision of the Big Crunch focuses on the slow, gravitational convergence of all matter and energy. Future computational simulations, operating with levels of precision far beyond what is possible today, will allow scientists to visualize how matter behaves under the extreme compression that accompanies cosmic contraction. These models may reveal new states of matter that can only exist within a universe approaching collapse. The question of entropy and information will also shape the future of the theory. If the universe contracts, what becomes of the immense quantity of information produced by life, technology, and cosmic evolution? Researchers in information physics are exploring whether there exists a fundamental limit to how much information can be compressed into a finite region of space. Some have proposed that the Big Crunch could function like a cosmic reset, preserving only the most fundamental patterns of physical law, while allowing the next expansion to begin with new possibilities. Such ideas connect cosmology with the philosophy of computation, suggesting that the universe itself might behave like an immense system capable of processing and renewing information. The cultural and educational future of the Big Crunch will likely become more holistic as humanity grows more connected with cosmic knowledge. As space science becomes part of everyday awareness, the idea of a finite and cyclical universe may gradually enter the shared imagination of future civilizations. Rather than being interpreted as an apocalyptic catastrophe, the Big Crunch may come to be seen as a natural rhythm of the cosmos, much like the setting of the sun that prepares the sky for the coming dawn. Humanity's relationship with cosmic endings may shift from fear toward acceptance and even quiet reverence. Ultimately, the future of the Big Crunch invites us to look at the stars with a renewed sense of wonder. Whether the universe expands forever or eventually gathers itself again, the search for answers continues to inspire human curiosity. Scientists will refine their measurements. Dark energy will remain one of the great mysteries to unravel, and gravity will continue its silent influence across the cosmos. Yet within the possibility of contraction lies a profound promise that nothing in the universe is truly lost. In the heart of convergence rests the seed of future creation. The Big Crunch may represent not only an ending, but the final link in a cosmic chain that ensures the universe always knows the path back home. We now arrive at a moment when words and numbers gradually grow quiet, allowing only the essence of the Big Crunch to remain within our imagination. To contemplate the Great Contraction is, in many ways, an exercise in humility and in accepting the impermanence of all things. Throughout this journey, we have seen that the universe is not an endless stage of cold dispersion, but something that resembles a living breath. If the Big Bang was the great inhalation, the beginning of a vast and luminous dream, then the Big Crunch is the final exhalation, the moment when the cosmos gently closes its eyes and gathers its lights once again. It becomes a perfect metaphor for rest. Just as we, after a long day filled with activity and thought, seek the comfort of a pillow and the quiet safety of home, the universe itself seems to carry a similar inclination, a return to its original source, to that state where distance, time, and separation did not yet exist. In this quiet closing vision, we can imagine the majesty of that distant future. Galaxies that for billions of years shone alone in the ocean of space now begin to approach one another like old travelers meeting again after a long journey. The space between stars, which once appeared impossibly vast, slowly shortens until the sky becomes a single, radiant embrace of light. There is no violence in this process, only the inevitable strength of gravity fulfilling its role as the great unifier. The poetry of the Big Crunch lies in the understanding that nothing is truly lost. Every atom that once formed a flower, every photon that departed from a distant star, and every thought that ever crossed a conscious mind is carried back toward the same center. It is a celebration of absolute connection, where the many forms of existence gently dissolve into the simplicity of their shared origin. From a philosophical perspective, the Big Crunch teaches that an ending is not the opposite of a beginning, but its necessary completion. Without gathering inward, expansion would lose its meaning. It is through finitude that beauty becomes precious. If the universe were to drift forever in endless dispersion, each moment would fade into the insignificance of infinite time. Yet in a universe that eventually closes upon itself, every second becomes a treasure, every light a miracle, every conscious experience a rare witness to existence. The Big Crunch transforms the cosmos into a complete work of art, one that has a beginning, a middle, and an ending that quietly contains the promise of another awakening. It echoes the philosophy of eternal return, suggesting that life and matter may be patterns the universe enjoys repeating, as it refines its cosmic symphony with each cycle of expansion and contraction. There is also a certain peace in imagining the final state of space and time. The rising heat is not a flame of destruction, but the warmth of a cosmic heart beating with full intensity once again. The growing density is not a crushing force, but the gathering of all universal experience into a single seed of pure potential. In the Big Crunch, the universe becomes its own archive, storing its entire history within a point infinitely small and infinitely rich. It is the moment when the journey pauses, so that essence itself may rest. And within that rest lies the quiet promise of what may come next. The silence that follows is not the silence of extinction, but the fertile silence of a blank page waiting to be written again with new laws, new stars, and new forms of life that may one day look up at their own sky and wonder about the path back home. As this story draws gently to a close, allow the calm of this vision to settle around you. The universe is governed by laws of extraordinary symmetry and beauty, laws that may be difficult to fully understand, yet strangely comforting to contemplate. We are part of this great cosmic organism. We are the stardust that, for a brief moment, has gained the ability to reflect upon the universe itself. And just as the stars will one day return to the center, we too can find peace in the act of returning inward. The contraction is the final embrace of nature, the gesture of a mother gathering her children after a long day of play. It is the destiny of everything, both vast and small, to return to the place where light never disappears, but simply gathers itself into a quiet and eternal brilliance. Feel now the gentle weight of your body and the steady rhythm of your breathing, aligned with this cosmic pulse. The Big Crunch reminds us that rest is a fundamental right of everything that exists. There is no hurry, no fear, only the slow and constant pull of gravity guiding all things toward unity and deep calm. The universe ends in light, warmth, and togetherness. And you, as part of this immense story, share in that same destiny of serenity. Allow the concerns of the day to dissolve into the vastness of cosmic contraction. Everything is returning to its place. Everything is finding its balance. The cycle closes with the perfection of a circle drawn by the hand of eternity. I hope this journey through the depths of the Big Crunch has brought clarity to your mind and calm to your heart. If you enjoyed this quiet exploration of the universe, consider subscribing to Cosmos for Rest so we can continue discovering the mysteries of physics and astronomy together in peaceful moments like this. You can also share this story with someone who might appreciate a moment of reflection and rest, and explore the other journeys waiting in our library of calm science. Now allow the final silence of this story to become the beginning of your deepest sleep. The universe is gathering itself. The lights are blending together and time slows so that you may rest. Feel the gentle embrace of gravity, the warmth of unity, and the peace of return. The mystery has been revealed, the journey completed, and the safe harbor is near. Sleep with the quiet certainty that you are part of the cosmos and the cosmos is part of you. Good night, and may the science of rest guide you into calm and endless dreams.